Let's take a look at the horizontal drilling and stimulation processes that have made shale exploration so successful. A drill bit is mounted on the end of the drill pipe. As the bit grinds away, a mixture of water and chemicals called mud is pumped into the hole to cool the bit and flush the cuttings to the surface. The mud also cakes on the walls of the wellbore, keeping it intact. Similar to a vertical well, the hole is drilled to just under the deepest fresh water near the surface. The drill pipe and bit are then removed. Surface casing is inserted into the drilled hole to isolate the fresh water zone and also serves as a foundation for the blowout preventer, a safety device that connects the rig to the wellbore. Then, cement is pumped down the casing and out through the opening of the shoe at the bottom of the casing. It is then forced up between the casing and the hole, sealing off the wellbore from the fresh water. The cementing process prevents any further contamination of the freshwater aquifers. The pipe and bit are lowered back down the hole to drill through the plug and cement, and continue the vertical section of the well to approximately 500 feet above the planned horizontal leg. This depth is called the kickoff point, where the curve will begin so the horizontal section can be drilled. Up to this point, the process is the same as drilling a vertical well. Again, the pipe and bit are pulled out of the hole, and a downhole drilling motor with measurement while drilling instruments is lowered back into the hole to begin the angle building process. The distance to make the curve from the kickoff point to where the wellbore becomes horizontal is just under 1/4 mile. Once the curve is completed, drilling begins on the well's horizontal section, called the lateral. The pipe used to drill the well measures 30 feet in length and weighs approximately 495 pounds each. It takes over 350 pieces of pipe weighing nearly 87 tons to drill a 10,500-foot well. At various stages of drilling, the pipe is taken out of the hole for tool and bit changes and put back in. This process is called tripping pipe. When the targeted distance is reached, the drill pipe and bit are removed from the wellbore one last time. Production casing is now inserted into the full length of the wellbore. Cement is again pumped down the casing and out through the hole in the casing shoe, forcing the cement up between the casing and the wall of the hole, filling the open space known as the annulus. Casing the well is a very important process because it permanently secures the wellbore and it prevents hydrocarbons and other fluids from seeping out into the formation as they are brought to the surface. At this point, the drilling rig is no longer needed. A temporary wellhead is installed and the location is prepared for the service crew who will perf, frack, and prepare the well for production. The first of these steps is to perf, or perforate the casing. A perforating gun is lowered by wire line into the casing to the targeted section of the horizontal leg. An electrical current is sent down the wire line to the perf gun and sets off a charge that shoots small holes through the casing and cement, and out a short distance into the shale formation. The perf gun is then pulled out of the hole. Next, because the shale is tight or compressed, the well will have to be fracked. Known as hydraulic fracturing, this is a process where water, sand, and chemicals are pumped into the wellbore and down the casing under extremely high pressure. As the mixture is forced out through the perforations and into the surrounding rock, the pressure causes the shale to fracture. This creates a fairway connecting the reservoir to the well and allows the released gas to flow to the wellbore. Next, a temporary plug is placed at the heel or left side of the first stage frac. The plug closes off or isolates the perforated and fracked section of the wellbore so that the second stage section of the horizontal leg can be perforated and fracked. This process of perfing and fracking can be repeated several times to cover the entire horizontal distance of the wellbore. Once fracking is completed, the plugs are drilled out, allowing the gas to flow up the wellbore. The next step is to install a permanent wellhead, also known as a Christmas tree, and other necessary surface equipment. A pipeline is then built to transport the gas to the pipeline network. As field development expands, additional pipeline infrastructure is built. Thanks to the vision and persistence of those who have perfected these new technologies, shale plays across the U.S. have become an innovative and highly productive source of new energy for our country.
Now, we've been hydraulically fracturing in the country, okay, and actually in Louisiana for many decades. But with the development of the Haynesville Shale and the new technique of being able to drill vertical and then laterally and having laterals hydraulically fractured as much as, you know, anywhere from 1,000 to 10,000 feet, this has changed and revolutionized the oil and gas industry as we know it, not just in this country, not just in our state, but it'll eventually be the entire world. So the fracking process is a very safe process. It's been studied many times by the EPA and different federal agencies and state agencies have looked at it, and it's a very safe process.
How is it used to get oil and gas out of the ground?
Well, basically what they do, they use a combination of water and sand and very, very few chemicals. They like to talk about the chemicals because there are chemicals in it, but the reality is the chemicals represent 0.5% of the makeup of the let's say cocktail solution that goes in. And under high pressure, first thing they do, let's say you have a lateral of 10,000 feet or 5,000 feet and you want to hydraulically fracture it, where you go in there and you do it in different stages, maybe 1,000 feet at a time, and you shoot holes into the pipe and the casing, and then you pump under pressure, a great deal of pressure, the water, sand, and chemicals into these holes that are in the pipe, and goes into the formation, and with a great pressure it fractures it. The shale plays are like slate, if you think about it in that way, and so then when it's fractured and they split open, it only goes about 80 feet in both directions. It doesn't go to the surface like, you know, a lot of these people that like to talk about hydraulic fracturing. It just goes about 80 feet. And the sand, the reason the sand's put in there, because the sand acts like little marbles, so to speak, because the shell is very tight and it'll compress, and by doing so it'll close back up. So you use the sand to keep the shell open. And that's basically the process. It allows more production and more gas. And I'll give you an example. When you drill a well in the Haynesville Shale, for instance, we've been drilling in the Haynesville for many, many years, but it's only 200 feet thick. And you don't get enough production in 200 feet, and consequently it's uneconomical. But now you can drill into the Haynesville and go out 5,000 feet, in some cases 7,000 to 10,000 feet. So you have a 10,000 foot pay zone now versus a 200 foot pay zone. And that is what's going to revolutionize the oil and gas industry in the United States.
What has this meant to Louisiana in terms of jobs and tax revenue?
Well, the jobs have been, you know, at one point we had as many as 140 rigs drilling in the Haynesville, and over 60,000 jobs. And the economic impact is tremendous. The studies that we've had done, annual budgets of, you know, anywhere from $10 to $15 billion a year. It's big, and where it's really paying off is the fact that we've now created all this gas we're going to be able to export in Louisiana, but the big players, the guys that are really doing well by this, it's not the oil and gas companies, it's our petrochemical industry in the state of Louisiana. All these new projects that are coming here, it's because we have cheap, abundant natural gas.
We understand that you have some concerns about a movie that's just recently been produced.
Yeah, well, you know, there was one prior to this one called Gasland. Now we have the Promised Land, and of course it's once again it's Hollywood hype, and that's what it's all about. It's actually it was funded by partially funded by one of the OPEC countries, and you know, let's face it, the OPEC countries as well as Russia aren't excited about this new shale play business, because it's going to make companies less dependent on foreign sources of oil. But the new movie is got a great star, Matt Damon. I like him. Environmentalists may like the movie, but very honestly, it's all Hollywood hype, and there's not any facts to it at all.
What does the movie show for people that may not be familiar with it, and then tell us what's true and what's false?
Well, what it shows, it says that the oil and gas industry is going to pollute their land and rivers and streams and water aquifers by using the technique of hydraulic fracturing. And it doesn't give any facts in it. It doesn't really show any reason it will, but they say it is. And just a mere fact that they're out there saying those kind of things, even though it has no true science to it at all, it's still scary for people that don't understand and don't see it. That's, when we started the Haynesville Shell, the very reason that we went up there, we developed an animation on it. We have had town hall meetings to explain to people, because you do have environmental groups that get out and talk about these things, and the sad part about it, they don't have to have any science or any facts about what they do. They just say it, and they reach the public, and so we need to let them know that it is a safe process. And we've had the same issues in Louisiana. People get scared, and understandably so. I appreciate that, and we in the industry have to do a better job of letting them know that that's not going to be the case.
Bottom line, what would you like people to keep in mind about this process?
Well, the bottom line is it's a safe practice, and the oil and gas industry in the state of Louisiana and throughout the country is not about to be doing any kind of practice that could be harmful to the water aquifers and the streams of this country.